So, welcome to ECE223 or electromagnetics. Okay, simula tayo ng discussion. So, ito nga pala yung mga chapters na pwede nating matake for the whole semester. But I think hanggang chapter 5 lang tayo. Gawa ng masyadong malawak yung electromagnetics. Kagaya nitong transmission line. Masyadong malalim na yung electrical knowledge yan, ano? So, yung transmission line kasi natin, so, makukuha pa natin yan sa ating 4th year, supposedly, ano? So, dito muna tayo siguro. Maybe we can go up hanggang sa chapter 6, ano? Pero ito, dahil masyadong mahaba, so, hanggang 5 or 6 lang tayo. Anyway, so let's begin our discussion with chapter 1, syempre. So, none other than vector analysis. Okay, so bakit kailangan nating mag-vector analysis na naman? Or bakit natin kailangan mag-take ng vector analysis? So, kung naalala natin sa ating Physics 1, which is yung ating Physics for Engineers 1, ano? So, na-cover doon yung kinematics, yung vectors, di ba? Yung tinatawag nating statics. Okay, so malaki yung naging ano natin doon, no? So, vector. So, kung naalala natin, when we say vector, that is actually values that have magnitude and direction. So, when we say, halimbawa, force, that is considered as a vector. So, when we say force is equal to 5 Newton, 90 degrees, ano? Pwedeng ganun, ano? 5 Newton, 90 degrees. Okay, 90 degrees, yun yung kanyang direction. So, meron tayong mga ganun. Pwede rin namang displacement vector. For example, 360 degrees, 360 meters north. Okay, pwedeng ganun, ano? So, maraming form yung vector. Pero dito, sa ating electromagnetics, bakit ba tayo kailangan matuto ng vector analysis? So, isang dahilan dahil almost all of the computations here in electromagnetics involves vectors. At dito, yung vector natin ay hindi nakatulad nung sa ating physics na 2-dimension lang, x and y lang, ano, yung coordinates natin, or x and y lang axis. So, dito yung ating vector ay naglalay sa free space, ano? When we say free space, that can be that can be in a rectangular coordinate system. Kaya lang 3-dimension. Okay? So, meron na tayong third coordinate. Okay? So, magpatuloy tayo, no? So, vector analysis. So, vector analysis is a branch of mathematics that deals with quantities that have both magnitude and direction. So, obvious naman, no? Vector, quantity that has magnitude and direction. Then, when we say analysis, yun, pag-aaralan natin syempre vectors. Okay? So, it is all about vectors. Okay, let's have first a review. Scalars and vectors. So, when we say scalar, alam na yan, those term refers to quantity whose value may be represented by a single real number. Okay, it can be a positive or negative number. Okay, the x, y, and z we use in basic algebra are scalars, and the quantities they represent are scalars. If we speak of a body falling a distance L in a time t, or the temperature T at any point in a bowl of soup whose coordinates are x, y, and z, then L, small letter t, and big letter T, x, y, and z are all scalars. Other scalar quantities are mass, density, pressure, volume, resistivity, and voltage. So, ano yung kailangan nating tandaan sa scalar? It is also a quantity or a value that doesn't have a direction. Okay, yun lang yung kaibahan niya sa vector. Scalar is also a value that but doesn't have a direction. Unlike sa vector, so vector quantity has both magnitude and a direction in space. Mas madalas nating nakita ng physics yung sa 2 dimension lang, ano? Bawa yan, ay yung vector mo, di ba? Commonly, vector is represented by an arrow. So, ganun din dito. Kaya lang yung arrow mo ay nasa free space. Kumbaga, nakalutang siya, no? Hindi na katulad nung alam nating vector na ganito lang, nasa 2 dimension, x and y lang. Or nasa plane lang siya, no? So, what are the examples of we are concerned with 2 and 3 dimensional spaces only, but vectors may be defined in n-dimensional space in more advanced applications. So, merong vector na defined in n-dimensional space, ano? Ibig sabihin ng n, so mas mataas pa sa 3, no? Hindi natin alam kung ilang coordinates yun, ano? Pero dito sa electromag, magpo-focus tayo sa 3-dimensional. So, bigyan ko lang kayo ng pwede nating ma-take, no? So, kung natatandaan yung Cartesian coordinate, so, lalagyan lang natin na isa pang axis yon or isa pang coordinate axis. Then, in the future, near future, so, pwede rin nating ma-take yung spherical and cylindrical coordinates. Ibig sabihin, you're considering points inside a sphere or a cylinder. So, may iba na ngayon yung coordinates mo, hindi na siya x and y. Okay, what are the examples of vectors? So, we have force, alam natin yan. Force, velocity, acceleration, and a straight line from the positive to the negative terminal of a storage battery are examples of vectors. So, una, ito, malinaw sa atin to yung force, ano? It can be upward force or downward force. Mga ganun, ano? Basta meron siyang direction. So, yung velocity. So, baka nalilito pa about velocity and speed. So, ang kaibahan lang nila, speed is a scalar quantity, while velocity is a vector. So, anong pagkakaiba? Direction. Okay? Also, acceleration. Ganun lang din yun, ano? And a straight line from positive to negative terminal of a storage battery. So, di ba yung ating battery ganyan, let's say, ba, electric field na lang. So, andito yung positive side natin, negative, ano? So, merong mga particle dyan, ano? Positive, yung proton, ano? Then, electron. So, unlike charges, attract each other, ano? So, nagkakaroon ng direction yung movement ng ating particle. Okay, so from our physics to yan, ano? So, now, so fields may be defined mathematically as some function that connects an arbitrary origin to a general point in space. So, when we say field, it can be a scalar field or a vector field. We usually associate some physical effect with a field, such as the force on a compass needle in the Earth's magnetic field, or movement of smoke particles in the field defined by the vector velocity of air in some region of space. So, when we say field, so kagaya na example, force on a compass needle. So, parang meron kang tutukoying space, then yung isang point dun sa loob ng space na yon is relative, ano? It depends upon the magnetic field, ano? Ganun yung ibig sabihin ng field. Okay, it can be scalar or vector. Ibig sabihin, if that is a scalar, in every different space in that field, so naiba yung value niya, no? Pwedeng maiba. Also, yung vector din. Pwedeng maiba yung value or yung magnitude. Also, the direction of the vector. Okay, so later on, papaliwanag natin na mas malalim yung vector field. Okay? So, meron tayong topic dyan, ano? Vector field. So, note that the field concept invariably is related to a region. Some quantity is defined at every point in a region. At so, ito yung sinasabi ko na in every point in a region or in a field is defined, ano? Of course, by a vector or a vector field or an equation, ano? So, yung vector kasi natin, naalala natin sa physics. So, given lang yung magnitude tsaka direction. Dito, yung vector natin ay equation. So, both scalar fields and vector fields exist. For example, the temperature throughout the bowl of soup. So, halimbawa, consider natin yung sabaw sa mangkok. So, yung sinasabi sa vector field or scalar field. So, in every space dun sa ating, in every point of space dun sa ating bowl of soup. So, merong definite or unique temperature yung isang particle doon, ano? In every space in that field or bowl, naiiba yung temperature. Okay? Sana nakakasunod. So, the gravitational and magnetic fields of the Earth, the voltage gradient in the cable. So, ito yung sinasabi ko na malalim na application na ng tawag din ng electromagnetics, yung voltage gradient sa cable. And the temperature gradient in the soldering iron tip are also examples of vector fields. Ito kasi, ibig sabihin, varying yung vector. It depends on the point or the position of the vector. The value of a field varies in general with both position and time. So, yun, no? Sa pool natin, pwedeng sa position or sa time siya, no? Dependent. Okay. So, now, let's have the vector algebra. So, sa ngayon siguro malabo pa yung vector field, pero napakadali lang pala ng pagka nakita nyo na yung mismong equation. Okay? So, vector algebra muna tayo. So, yaman din lamang at aralin natin yung vector analysis na yan. So, dapat matuto rin tayo ng vector algebra. So, pinapauna ko na, some of the operations are just like an ordinary algebra operations, ano? But some are almost the same but completely different. Wow. So near yet so far, ano, parang ganun. Okay, let's begin. So, the addition of vector follows the parallelogram law. Kung naalala sa ating physics. So, and we are going to add two vectors. So, we can use parallelogram law. So, kung naalala pa yung parallelogram law, no? So, ito lang, magpo-project lang tayo ng line. So, halimbawa, ito yung dalawang vector mo. Vector A and B. So, mag-project ka ng vector A dito. So, meaning, magpo-project, you copy the same angle. So, itong angle na to, dapat makuha mo. Then, you project this line here. So, when you say projection, same angle, same length. And also, this line, or this vector, vector B, you project from this point, ano? So, doon sa tip ng ating vector A. So, ayun, na-project natin. Then, we can use from this, we can use what? Yung ating tinatawag na cosine law. Okay, yung A squared is equal to B squared plus C squared minus 2 BC cosine A. Mga ganun, ano? Pwede nating magamit. So, dito, ito yung angle na kailangan natin. Diba? If we're going to use parallelogram law. Okay. So, pwede rin naman yung head to tail method. So, yung pagduduktongin mo lang yung dalawa, then, ayun na. Draw a straight line from the end of the vector A up to the head of the vector B. So, then connect. So, itong vector na to, yun yung kanyang vector sum. Also, we can use yung ating cosine law. Okay? So, diretso ba tayong mag-add ng A plus B lang, ano? So, hindi. So, vectors in 3 dimensions may likewise be added by expressing the vectors in terms of 3 components and adding the corresponding components. Okay? So, kagaya nung sa ating physics, when we're going to add vectors, so we need to express that in terms of x and y component. So, naalala ba yung, di ba, yung summation of x and, di ba, fx, fy. We get the summation, di ba? Hahatiin mo muna. Halimbawa, itong ating vector A. So, that is complete, malinaw na meron siyang x and y component dahil hindi naman siya horizontal or vertical line. So, you need to get this component. So, ito yung kanyang x component. And ito yung kanyang y component. Di ba? AY, then AX. So, to get that, we use yung ating SOHCAHTOA. Di ba? Nagmamanipulate lang tayo ng right triangle para makuha yung x and y component ng isang vector. Then, kung halimbawa you have two vectors, so you get you add all of the x component, so you get the total or resultant x. Then you get you add all the y components, so you get the resultant y. Then, what's next? If you have the total x components like this, so for example, this is the total x forces or vectors, and this is the total or resultant y component. So to get the vector sum of these two, so you connect this one with this one. So this is the resultant vector, no? So we name it R. So basically, you're going to apply Pythagorean Theorem here because you form a right triangle. So kung naalala, ganun, no? Ganun lang din dito yung concept nun. Okay, so kaya lang, anong pinagkaiba? So mamaya makikita natin. No? So tandaan natin, no? We're going to express vectors in terms of three components. So dito sa ating electromag, we're going to use yun nga yung three components or three coordinates. Unlike dun sa ating vector sa physics. So now, vector addition obeys the commutative law. So ito yung yung pagka nagkapalit ng ng order. Halimbawa yung A plus B, that is also B plus A. Gumagana dito yun sa vector algebra. Then vector addition also obeys the associative law. So something to do with regrouping. So kapag nagregroup ka using parentheses, dito A plus B quantity plus quantity B plus C. So kapag nilipat mo yung parentheses, same lang din yan ang kalalabasan. Okay? Sabihin kahit pagbalik-baliktarin mo yung values na yan, walang problema. The rule for the subtraction of vectors follows easily from that for addition. For we may also express A minus B as A plus quantity negative B. So same lang sa algebra, no? So pwede mong alisin yung negative na yan. So, ipa-factor out mo. Halimbawa, positive or negative. So, pwede, So, you're going to factor out positive. So, positive, then quantity negative B. So, ganun lang, So, kapag nilabas mo naman, so, you distribute that. So, you have A minus B. Simplifying this one. Okay? Then, vectors may be multiplied by scalars. So, tandaan, Vectors may be multiplied by scalars. The magnitude of the vector changes. Tandaan, the magnitude of the vector changes. Nababago yung magnitude, but its direction does not when the scalar is positive. Although, it reverses the direction when multiplied by a negative scalar. So, pwede tayo mag-multiply ng scalar sa vector. Walang kaso doon, Same operation. Kanya lang, for example, you have a scalar value R, so you can multiply directly with a vector quantity A. Okay, so vector. Ganyan tayo magsulat ng vector, Naka-bold yung letter. Then mostly capital siya, Minsan naman, ina-identify lang na vector R, pero small letter, Pero to be uniform, so gamitin natin yung bold letter na A. So let's go back with this. Okay, vectors may be multiplied by scalars. So pwedeng mag-multiply. So ano nangyayari? So nababago yung magnitude ng vector and the direction. Kung positive yung scalar na minultiply mo, so hindi magbabago yung direction. Kapag ka naman negative, syempre magbabago. Ano yung positive at negative na yun? Yung sign ng vector. So you can have a negative or positive vector. Diba? So that sign tells us the pangit yung A. Nantok na ako. Okay, that sign denotes the direction. Okay. So multiplication of vector by scalar also obeys the associative and distributive laws of algebra leading to, okay. So pansinin no, if we have r plus s times a plus b, so that is also equal to, okay, so kung i-distribute natin, so r times a plus b, then s times a plus b, parang ano lang, no? Yung kagaya no sa algebra, yung distributive ano, property. Then, okay, so we have RA plus RB plus SA plus SB. So parang fold method nga lang din, ano? Okay. So two vectors are said to be equal if their difference is 0. So, kagaya lang din to ng karaniwang algebra. Then, let's have now the rectangular coordinate system. So, ito na, ano? So, makinig. Okay, the rectangular coordinate system, yung karaniwang alam natin, yung Cartesian plane lang, ano? But dito sa ating vector analysis, sa ating electromag, kagaya na sabi ko, tatlo na yung coordinate system natin. Okay, imagine this as our, bawa itong dalawa lang na to, ito yung ating Cartesian plane, di ba, ng karaniwan. Pero dito, sa rectangular coordinate system dito, 3 dimension na. So ito ngayon yung ating x. So yung, kung na-imagine natin, this axis is going outside of the screen. So palabas siya, pointing towards us, ano? Then this axis is y. Then this one is z. Third axis. Okay? So tandaan ano yung yung order niya, no? X, y, and z. Okay? So yung meron sa book sabi ay yung direction ay right hand screw, no? Or right hand spinning screw. Sabihin, yung ikot niya, pag ganun, counterclockwise. So that denotes the order. So x, y, and z. Okay? So kaya kapag ka binigyan ka ng point, so kung meron kang tatlo, ang order nun, so for example, you have point P, that is x, y, and z, no? Okay? So this one now, so this is positive x, ano? Then this is negative, positive y, and positive z. So kailan ka ngayon magne-negative? So kung positive x ka, the direction of the axis is going towards you. Okay, palabas siya ng screen. Kung nagsusulat ka sa papel ngayon, that is going outside the paper. Okay? Then, kung negative x ka naman, so dito yon naglalay sa likod. Direction of the axis is going towards the screen or away from you, no? Palayo sa'yo. Then, kapag negative y, napakadali. Pakaliwa. Diba? Then, negative z, pababa. Okay, sana malinaw ito sa inyo. Okay. So, doon naman sa paglilabel, doon sa paglalagay ng points ano, doon sa ating axis. So, dapat consistent lang, pare-parehas ka ng paglalagay para maganda yung kalabasan ng yung graph. Eraser tayo, bura-bura. Nabura ko pala yung z. Okay, so this is positive z. So this one now, okay, palit tayo ng kulay ng, so this plane, okay, so this plane is the x is equal to 0 plane, no? X is equal to 0 plane. Okay, sana naiintindihan. Bakit naging x equal 0? Dahil dito sa plane na to, ang value ng x mo ay 0. Okay? Then, change tayo ulit ng color. Then, this plane, okay, this plane, kung naalala, no? Kung naiintindihan, sana. So, this plane is y is equal to 0 plane. So, dyan sa plane na yan, tagusan yan, ano? So, yung ating y dyan ay 0. And dito sa plane na ito, dito, this plane, is the z is equal to 0 plane. Okay? So, alam natin kung ano yung plane na tinutukoy when we say y is equal to 0 plane, z is equal to 0 plane, and x is equal to 0 plane. Then, let's have an example on how to plot a point in a rectangular coordinate system 3-dimension, so 3D. So, this is how to do it. So, try natin, mahirap kasi mouse lang gamit ko. So, x, y, z. So, wag malilito sana, So, una, so this is x, y, and z. Kunin muna natin x. So, if we're going to plot x, so 2, kanyang value. So, bilang ka 1, 2. Okay, so ito yun, So, draw ka ng line dyan. So, meron kang positive na y. So, susunod mong hanapin yung y. Okay, so 4, So, dito ka sa y-axis, positive. So, kanan. 1, 2, 3, 4. So, ito. So, paano ngayon i-drawing mong line dyan? Is it a vertical line? Or is it a parallel line to the x-axis? So, nga pala, I forgot to mention that 3-axis or 3-coordinate axis is perpendicular to each other, So, yung x natin, perpendicular siya kay y-axis. Then, si y, perpendicular kay z. And also, si x-axis natin ay perpendicular kay z. So, obvious naman yun, Sana naintindihan doon sa part na yun. So, continue tayo sa ating pagpa-plot. So, syempre, kung 4 tayo dito, ang ito-drawing nating line, parallel sa ating x-axis. So, mag-drawing tayo na kunyari parallel siya, Draw tayo dyan, Then, okay. Ayan na, nag-meet na yung ating x and y. Ito siya ngayon, Nag-meet dyan. Then, hanapin natin yung z. So, 6, 1, 2, 3, 4, 5, 6. So, ito. So, draw ka ngayon ng line dito. Horizontal line. Sana nasusundan yung pagpa-plot. We're actually drawing a prism, para mas madaling intindihin. Then, connect it to, saan natin ko-connectahin? So, saan tayo kukuha ng pang-connect dito, So, dito sa y. I-extend lang natin, yung y. So, 4 tayo. Then, draw tayo ng vertical line dito. Okay? So, ayun, nakita natin, nagtama na yung y and z. So, kung saan nagtama, yun yung part ng ating, or isa sa vertex ng ating mabubuong prism. Then, dito sa point na to, kailangan nating mag-drawing ng parallel line again sa x-axis. Okay, parallel line. Kunyari, parallel siya. Then, saan natin kukunin yung intersection dito para makabuo tayo ng prism? So, dito, sa x. Kung nasan yung value ng x. So, sa 2. So, draw tayo ng vertical line. Ayun, nag-cross na sila ulit. Then, ganun din dito sa intersection ng x and y. Draw lang tayo ulit. Then, ayan. Nakikita natin, kung magdodraw tayo ngayon dito ng horizontal line, magtatama na silang dalawa. Then, buuin lang natin yung ating prism. So, ayun, Okay. So, ang pangit ng drawing. Mahirap kasi mag-drawing sa... Pero kung magdalala, meron ako dito. Pinakita ko lang kung paano siya tinetrace, Kung paano i-plot. So, alin ngayon dyan yung ating point P. So, tandaan, kung ito yung ating origin, so ito yung origin pa rin, kung saan nag-intersect yung tatlong line or yung tatlong coordinate axis. Dun tayo sa kanyang opposite corner. Okay? So, nabuo na kasi natin ngayon yung ating prism, So, ito ngayon siya. And, titrace ko lang, Yan. Here we go. Yun. Hirap. Mas madali sana ako sa whiteboard to. Okay, so na-imagine ba yung prism sa ating, hindi na natin matukoy kung anong quadrant yan, ano? So dito sa ating gawin ng nasa ano siya, nakapatong sa z is equal to 0 axis. Okay, and then nasa kanan ng y is equal to 0 axis, then nasa likod ng x is equal to 0 axis. Nandito siya sa part na to, ano? Ito yung ating prism, di ba? Alin ngayon dyan yung point natin na hinahanap, yung point P? So, ang sabi, nasa opposite corner ng ating pinaka-origin. So, ano yung opposite ko? Ito yung corner ng ating prism, yung origin, isang corner. Yung opposite niya, ito, malinaw. Okay? So, ito yung ating point P. Tinagalan ko para malinaw sa atin yung pagpo-plot. 2, 4, 6. So, and then we connect the line. We connect the 2 points pala actually. So, we connect these two. So, this is our vector. So, when we say, this is a vector, okay, P, no? When we connect these two points, the origin and our point P. So, nakabuo tayo ng vector dyan. Madalas, ang sinusulat dyan, or it is described by, okay, vector RP. Okay, so ganun siya, no? So, mas magandang drawing ito. Ayun. Ganyan yung difference yung drawing ko. So, sana malinaw sa atin, ano? So, bilang ka lang doon sa axis. Magsimula ka doon sa pagbibilang ng axis. Then, try to make a prism from those plotted points, ano? Okay. So, ito yung mas magandang drawing. So, ayun siya, no? Yung direction niya. So, from origin to our point. So, laging opposite corner. Okay, opposite corner. So, napapansin, yung vector na yan ay diagonal ng prism. So, dahil sa prism, ano, inabuo na yan. Yung figure na yan. Pupunta sa towards sa atin yung direction ng vector. Okay, so another example. So, vector point Q. Kung ipa-plot natin. So, positive 3. So, bilang ka lang. 1, 2, 3. Diba? 1, 2, 3. So, ito. Tantusan mo lang. Then, negative 2. So, pakanan, ano? Ay, pakaliwa, no? So, ito yung negative y mo. Positive y. So, pakaliwa siya. Sabihin natin, okay, negative 1, negative 2. Tantusan mo lang ulit. Ayan siya. Then, positive 5. 1, 2, 3, 4, 5. Tantos. So, from those points, okay, along the axis, coordinate axis, so you try now to create what? A prism, okay? So, project lang ng line. Kung naalala sa AutoCAD, o project ka lang ng line. So, itong point na to, gawa ka lang ng parallel line sa ating x-axis, di ba? Try nating project, ano? Kung paano siyang nanggaling. Itong point na to, project ka lang ng parallel line sa x-axis. Then dito, sa point na to, syempre, nandyan yung pinakataas. So, project ka lang ng vertical line. Then, dito sa point na ito, gawa ka rin ng vertical line. Then, sa mga intersections, tapos dun sa point na yan, gawa ka ng vertical line. Sorry, horizontal line pala ito. Okay. Ako ay naantok na. Horizontal, vertical line, this one. Projection. Then, dito sa mga point na to, gawa ka ng parallel dun sa ating x-axis. Then, sa intersection ng dalawa, gawa ka rin ng parallel. So, ang goal mo kasi dyan nga ay makapag-draw ng prism. So, diskartehan nyo kung paano, no? So, magbibigay ako ng example, ng sheet work. Okay, tignan natin kung maipa-plot. So this another example. So r is equal to negative 5, r, negative 5, negative 6, negative 6, point r, ano? So kung papansinin, puro negative. So yung x ay negative, so nandito sa likod. So 1, 2, 3, 4, sabihin natin ay 5 na, no? Negative 5. Then negative 6, so negative 6 sa kaliwa, ano? 1, 2, 3, 4, malayo, ano? Ulit. Okay. So 1, 2, 3, 4, 5, 6. So yun. Then we have negative 6 again, pababa. So 1, 2, 3, 4, 5, 6. Ayun, kunyari, accurate yung ating ano, no? So, kung napapansin, ito yung mga tinamaan niya, no? May na-cover niya sa ating axis. Ano na lang ang kailangan natin gawin, ano? Imagine mo ngayon yan. Imagine mo yung part na yan, ano? Nag-draw ako ng line mula dun sa origin hanggang dun sa mga tinamaan na points sa ating axis. Kung yan yung line mo halimbawa, hindi mo nakikita yung graph, yung broken lines na yan. Halimbawa, ito papakita natin. Oops. Halimbawa, ito. Burahin muna natin, ano? Tayo duplicate. Halimbawa, ito. Okay. Halimbawa, yung negative 5, negative 6, ano? Pakita natin ulit para malinaw. Yellow. Ayan. So, negative 5. Dito tayo ulit sa likod. 1, 2, 3, 4, 5. So, ito halimbawa, i-point natin, ha. So, i-cover natin tong line na to. Mula sa origin hanggang sa point. Then, negative 6. So, pakaliwa. 1, 2, 3, 4, 5, 6. Halimbawa, ito, ha. So, draw na tayo ulit. Then, negative 6 ulit. 1, 2, 3, 4, 5, 6. So, draw na tayo ulit. Hirap kasi nasa mouse lang. Okay. So, ito yung mga edges ng ating prism, ano? Yung part na yan, mga edges yan ng prism. So, kung ito yung origin mo, so, alam mo na agad kung saan siya papunta dapat. Dapat papunta dun sa opposite corner. So, from that edges, paano ka makakabuo ng prism? So, napakadali lang, ano? So, ito nakaharap sa ito eh. Itong part na to. So, ito should be a rectangle or square, ano? So, this is a rectangle dapat. Dahil negative 5, negative 6, negative 6. Then, this is inclined, ano? So, ayun. Bubuo ka na ng prism. Ganun lang yung concept ng pagpa-plot nito. Tapos, syempre, dito. Yun. Susundan mo lang yung shape na yan. So, saan ka ngayon maglalagay ng point? Pero, sa accurate na pagpo-point, syempre, gagamitin mo yung kung saan sila nag-i-intersect. Kaya kapag kayo ang nagpa-plot ng points, okay, gagamit kayo ng mas mainam graphing paper. Okay, then magagamit kayo ng ruler. So, medyo madugo or nakakalito talaga yung pagpa-plot sa una. Pero kapag natutunan, napakadali lang pala. So, ito ngayon yung origin, di ba? So, connect lang yung dalawang point. So, yun yung ating vector. Pointing away from the origin or from pointing towards the opposite corner of the origin. So, yung origin kasi natin, palaging tandaan. Yung origin, palaging yan ay isa sa corner. Okay, or isa sa vertex ng ating prism. So, ganun lang siya, no? Balik tayo. Burahin ko lang, Ari. Okay, tuloy tayo pala. Okay. So, let's have... Okay. So, pwede rin mauto ako at ipa-plot ko sa inyo na sama-sama sa isang Cartesian plane yung tatlong points. So, ito yung itsura nun, no? Pag pinagsama-sama sila. Then, pwede rin maging problem dyan. Tandaan natin. Pwedeng maging problem dyan. Ipakuha ko yung, kung tatlong points yan, pakuha ko yung area ng rectangle na mabubuo. Diba? So, napakadali lang yan kung papakuha ko yung area ng rectangle. Basta dapat meron kang length ng tatlong sides. Diba? So, ganun lang siya. Later on, matututunan nyo rin yung pagpo-plot. No ka nakaka-elite sa umpisa. Pero dapat, i-try kasi nyo na mag-plot. Okay? So, lalo na kung halimbawa sa point na to. Saan na yung ating cursor? Yun. Laser pointer. Diba, sa point na to, hindi mo alam kung anong line ang i-drawing mo. Kung vertical or parallel, ano? So, dapat, basta ang goal mo ay makapag-draw ng prism. Then, kung paano ko ginamit yung mga intersections kanina, kung paano mag-plot. So, dapat makuha nyo rin. Okay. So, vector components and unit vectors. So, ito na. To describe a vector in the rectangular coordinate system, let us first consider a vector R extending outward from the origin. A logical way to identify this vector is by giving the three components vectors lying along the three coordinate axes, whose vector sum must be the given vector. So, for example, meron tayong x, y, and z. Okay, then you're going to get vector R. So, nakapansin, ano, prism ulit. Okay, so the best way daw to define or describe a vector is by adding the three coordinates or the component vectors, which is x, y, and z. Okay, kukunin lang natin yung sum. Yung sum. So, madalas doon sa ating physics, magnitude and direction na lang. So, dito, ang mangyayari, i-add mo yung tatlo. Pero, hindi mo pagsasama-samahin. You're going to describe that by their sum. Okay? Sum sila, no? Magkakaiba yan ng direction. Kaya hindi mo pwedeng i-add ng diretso. Naintindihan? As is yan, ano? X plus y plus z. Okay? So, pwede rin mag-negative. Depende sa direction. Kung halimbawa, negative y, nandito kung dito tumuro yung vector mo, doon tumuro. So, negative y ka. Okay? So, tingnan pa natin para mas maintindihan. The component vectors have magnitudes that depend on the given vector, but they each have a known and constant direction. So, ayun, ano? Yung direction niya, ano, meron. And that is constant. This suggests the use of unit vectors. Having unit magnitude by definition, these are parallel to the coordinate axis and they point in the direction of increasing coordinate values. We reserve the symbol A for a unit vector and identify its direction by an appropriate subscript. Okay, thus a sub x, a sub y, and a sub z are the unit vectors in the rectangular coordinate system. They are directed along the x, y, and z axes respectively, as shown in figure. Okay. Then, if the component vector y happens to be 2 units in magnitude and directed toward increasing values of y, we should then write y is equal to 2ay. Okay, so sabi kasi, yung component vector ay merong magnitude. Saan ba yan? component vectors have magnitude. Okay, then also that has a direction. Constant direction. So, paano mo ngayon ihiwalay yung magnitude do sa direction while describing the whole vector? So, kailangan natin gumamit ng unit vector. So, that unit vector is the unit vector of the component vectors, which is x, y, and z. Now, para magkaroon ng distinction, so we're going to name the, or ano sabi doon? We're going to reserve the symbol A. Okay? So, ito yung gagamitin natin to denote that that is a unit vector. Okay? And also, the subscript tells the direction. So, kung anong component vector siya. And always, the unit vector is pointing what? Pointing away from the origin. No? Palaging pabuka, palayo sa origin. Ano? So, yun yung unit vector natin tinatawag. Okay? So, recap tayo. So, when we say component vector, so component x, y, and z. So, nahati, ano? Kung meron kang r is equal to x, y, and z, x plus y plus z, ano? Yun yung buong vector. So, x is equal to bx, b sub x, a sub x. So, this one tells the direction. Okay? Or also, this one tells that this component is an x component vector, no? So, bx or b sub x tells the magnitude of the x component. Same as with y and z. So, this one is y. Y and ano? Okay. So, yung may mga a, that is a unit vector. I-reserve natin yung small letter a, no? Then, yung subscript tells the direction. Then, this one tells the magnitude. But, etong b na to, hindi laging b, ano? Kahit anong, ano yan, ano? Kahit anong letter except for a. Okay? So, pwedeng may iba-iba yan, ano? So, depende sa representation. So, ito. So, yung ating vector, so, nagbumuo daw tayo ng vector, ano? From origin to the point P. So, this is our point P. So, paano natin ngayon i-describe yung vector na from origin to point P? So, nasabi ko, kapag tayo ay gumawa ng vector from origin to point P, so, we name it R sub P. Okay? So, kunin lang natin components. So, x, y, and z. So, what is the x component? Or the magnitude of x? So, we have 2. So, ano yung kasama? Yung unit vector x. Unit vector ng x. Ayun, no? 2a sub x. So, ganun lang kadali. Then, yung y component. So, 4. Positive 4. Then, yung unit vector y. Plus, dahil positive din yung 6, so 6a sub z. Wala. Yun yung ating vector r sub p. Or yung vector p natin, ano? So, from origin to point p. Ganun lang kadali. Okay, so another example, yung ating vector q. So, we have now positive 3, so 3ax, a sub x. Then, so negative siya, no? So, we have negative 2, a sub y. Then, plus positive a sub z. So, yun yung ating vector. Ganun na kadali. Defining this vector, no? This pink arrow. Then, point r. So, vector r sub r. Vector r, no? From origin, okay, so we have negative 5 a sub x minus 6 a sub y minus 6 a sub z. So yun, ganun lang kadali. Okay, sana malinaw tayo sa ating vector component and unit vector. So vector magnitude, unit vector, this tells the direction. Okay, so paano ngayon? Okay, pinagsama ko yung point P and Q sa isang graph, ano, or sa isang plot. Paano ngayon, since we have vector RP and RQ, no? So how about this vector? So vector from P to Q. Okay, we're are tasked to find vector from P to Q. So paano ngayon? So we get the difference of RQ and RP. RQ minus RP. Kung papansinin, we get the vector P from P to Q, ano? So yung direction ng vector mula sa P papunta sa Q. So we get that by subtracting R sub P to R sub Q. So bakit nagkaganon, ano? So imagine na lang ito para madaling intindihin. So halimbawa, meron kang sa x-axis mo, di ba? So you want to get the difference between 2 points, point A and B. Di ba? Paano ba kukunin yung difference na ito? Di ba? You subtract A from B. O ibabawas mo yung point na ito kay B. So you have B minus A. So yung direction niya, yung nauuna yung B. So papunta ron, ano? So halimbawa, nandito yung direction ng arrow. Burahin natin, ha? Nantok na ako. So halimbawa, papunta dyan. So to get the difference, okay, halimbawa, ito yung origin mo. Kung gusto mong kunin yung difference, probably you get the A, subtract B with A, ano? So A minus B ka dyan. Same lang din with this one. Okay? So ganun lang din dito, no? Since yung direction natin from P to Q, i-assume natin na ahead yung Q kay P. Kaya babawas natin yung nauna, which is Q. Okay? Imagine mo yung straight line na yan, arrow, nauna si Q, ano? So ito si Q, ito si P. Kaya babawas natin si P kay Q. So RQ minus RP. So sana malinaw tayo doon, ano? So paano natin ibabawas? So naalala, kinuha natin yung RQ, ano, which is yun. Now, let's operate. Okay, so RQ minus RP. So pwede rin ito yung gamit mo, ano? So doon mo lang din naman kinuha. So walang problema. So RPQ is equal to, so Q mo, no, sa for X, ano? So this is X, Y, and Z. So Q minus P ka. So dito 3 minus 2. Ayun. A sub X 3 minus 2. Then plus negative 2 minus minus 4. Yun. Then 5 minus 6. So tandaan yung order. Q minus P ka, ha? Kaya naging ganon. Okay. So 3 minus 2 is 1. So you have AX. Then negative 2 minus negative 4, minus 4 is equal to negative 6. So you have negative 6 AY. Then 5 minus 6 is negative 1. So you have negative AC. So kapag 1 lang yung magnitude, hindi na rin sinusulat. Understood na yon that any unit vector has a what do you call this? A coefficient of 1. At tandaan pa, when we say unit vector, that is a vector that has a magnitude equal to 1. Okay? Ang mahalaga lang doon yung direction. So, magnitude is 1 but different, but same direction. Okay? So, when we say magnitude, for example, a vector is defined or described by an arrow. The magnitude we say is the length of that arrow. Okay? In order to get the magnitude of B, and written as the what do you call this? Parang absolute B siya, no? So meron kang bar, dalawang bar, ano? Okay, so yun yung symbol ng magnitude, or simply B is given by, okay, magnitude is equal to square root of bx squared, or the square of the component of x, then, or the magnitude of x component plus magnitude of y component squared plus the magnitude of z component squared. So paano ba nangyaring ganun? Okay, screen. Sakit na ng mata ko. Okay. In color, so yellow gamitin natin. So since prism siya, di ba? So imagine this prism. Okay. Bawa yun yung prism na sinosolve natin. Bawa lang ah. Then this one is the origin. Okay. Sabi natin yung vector daw ay yung diagonal from the origin up to the opposite corner. Okay. So ito yung ating opposite corner, ito yung ating origin. So if we're going to solve for that diagonal, okay, the length of the diagonal will be equal to, how to solve that? So from our geometry, that is very basic, ano? You're going to solve for that. So you need this length. Remember that this one is perpendicular to this line, or this edge. Okay, so this edge is actually for example, this is x. Sorry, this is y. So this is y, so this is x, and this is z, the height. Okay, so parang resemblance lang siya nung ano, no? Okay, so kung ito ay x, y, and z, how to get this line? You need to get this line, or geometrically speaking, okay, this is the diagonal of the face. Okay, or diagonal of the base. Lumalabas yung pinakailalim ng prism natin. So ito yung z, walang problema, yan na yun. So you have 1 z, ayun ano. So how to get this one? So remember, this is perpendicular to this one. So x is perpendicular to y. So this is a right triangle. So to get this, pangalanan natin na what? Diagonal, ano? Diagonal ng face. And this one is our r, or yung vector. To get that one, you need to get the what? The length of this one, of course. You need to apply Pythagorean Theorem to this triangle. Also, this one is right triangle. So you have to get, okay, so to get the value of r, or the length of r, that is square root of d squared plus z squared. And how to get d squared, or d, how to get this? Okay, so you need to get the length of this. You apply Pythagorean Theorem to this right triangle. Remember, that is also a right triangle, so you have a right angle here. So in order to get d, that is equal to square root of x squared plus y squared. So malinaw, no? We substitute this value here. So we have r is equal to square root of quantity squared x squared plus y squared, quantity squared plus z squared. Then, ano nangyayari kapag naka-square yung square root? So, makakancel. So, you have now r is equal to x squared plus y squared plus z squared. So, ayun. Imagine that as a vector component, or magnitude of the vector. So, yung x squared, yung x, y, and z natin. So, doon nagmula or na-derive yung ating formula na ito. So, tandaan niya formula, no? For example, you want to get the magnitude of our vector PQ, ano? So, what are the magnitudes? So, 1, negative 6, and negative 1. So, ipasok lang natin. So, kung mapapansin na, iba na yung mga gamit na symbol. Okay, nasa inyo yan kung paano i-describe yung vector. Pero madalas ganito, RPQ, okay, RPQ sub x, RPQ sub y, RPQ sub z. So, this subscript tells the vector component. Okay, kung anong component siya ng ating vector. So, x, y, and z pa rin. Then, you substitute the magnitudes. So, RPQX natin, or x component, is 1. Then, y component is negative 6. Then, z component is also 1. So, we have now square root of 1 squared plus negative 6 squared plus negative 1 squared. Simplifying, you have 1 plus 36 plus 1, and then square root. You have now square root of 38 units. So, tandaan yung units, mahalaga. Okay? Then, you can also have the decimal. Okay, so square root of, we get the square root of 38, that is equal to 6.164. Okay, you can consider 3 decimal places. Okay, let's proceed. Unit vectors are not limited to this application. A unit vector in the direction of the vector b is what? Unit vector b. Okay, unit vector in the direction of b. Tandaan, iba yung vector component, unit vector ng ating coordinate axis. Okay, so you can also get the unit vector in the direction of that vector. For example, you have vector b. You want to get the unit vector of that vector. You want to get the unit vector in the direction of the vector given, which is b. So how to do that? You're simply going to divide the whole vector by its magnitude. Okay, so vector b divided by magnitude. Ganun lang siya kadali. So tandaan that the unit vector, the magnitude is 1. Ano lang ang mahalaga? Makuha natin yung direction ng ating vector. Okay, so let's try. We want to get the unit vector in the direction of PQ. Kung nasan yung direction niya, no? We get the unit vector. So pasok lang natin sa formula. So we have a RPQ that is equal to, okay, RPQ all over magnitude, which is 38 units. So substitute lang. So we have the whole vector a sub x minus 6ay minus az. Then we divide that whole vector by square root of 38. Then, okay, so minsan dito sa electromag, ginagawa, instead of dividing, you multiply that, you multiply each of the components by the fraction of that magnitude, ano? Parang nagdi-divide ka lang, pero ganito yung form niya. Okay? Ewan ko, pero ganun yung nakasanayan nila. Okay? And also, naalala ko pala, x, y, and z can be also I, j, k, you know? Yung a sub x na yan, in some books, I ang kanilang gamit, I, j, and k. So, let's proceed. So, 1, okay. Ayun, ano, dinistribute lang yung 1 over square root of 38. So, pwedeng ito na yung sagot mo. Wala nang problema. Masakto nga ito kasi included yung buong radical, ano? Yung tama, yung radical. Included siya. Instead of kunin with decimal, magra-round off ka na. Hindi na kompleto yung sagot. Pero kung depende sa tanong yan kung ano ba, consider 3 decimal places, then you need to get the decimal. Okay? So, kunin natin ano. So, yung 1 over square root of 38, so ito yun ano, a sub x over square root of 38, so that will be equal to 0.162. So, same lang din dito, iba lang yung sign. Then, yung 6 over square root of 38, that will be equal to 0.973. Okay? So, yun yung ating answer. So, 0.162 a sub x minus 0.973 a sub y minus 0.162 a sub z. So, ito yung ating unit vector. So, ang sabi, kung naalala, ang sabi ko kanina, yung unit vector, ang magnitude niyan ay 1. Ano lang ang mahalaga nating nakuha? Pansinin, ano? Ang sabi ko kanina, that the sign of each component vector ay what? Denotes the direction of the vector. So, pansinin, ano? Kung ang sign ito positive, ito negative, ito negative. Sa unit vector, parehas lang ang sign ng bawat isang component vector or component. Okay? Parehas ng sign. Okay? So, sabi ko, ang magnitude ng unit vector ay 1. So, itry ngayon natin. Let's get the magnitude. Di ba, square lang naman yan ng tatlo, no? So, we have 0.162. Antok na ako. Plus, okay, so negatives. Actually, kapag sa calculator, kahit di mo ilagay yung negative, kung i-square mo lang din, parehas lang yan, ano? So, 0. Pero ilagay na natin para, ano, di maligaw. 0.973 squared plus negative 0.162 squared. So we have now 0.9996 or approximately equal to 1. Pero we're going to try to get the okay. So kung gusto niyo makakuha ng saktong 1 kasi nag-ano tayo round off. Ganito naman yan kung gusto niyo kumuha ng saktong 1. Bawa kunin niyo ito. So 1 over square root of 38 yung ating yung x component natin, ano? Halimbawa, ayan. Store natin sa A. Tapos yung y component, so negative 6 all over square root of 38, i-store natin sa B. Then yung ating z component, equal lang siya sa x component natin pero negative. So gawin natin, okay. So negative A, ayan. Negative na. Then store natin sa C. So yung x, y, z natin ay naka-store sa ABC ng ating calculus. So, kunin natin, ano? So, alpha A squared plus alpha B squared plus alpha C squared. So, ang lalabas dyan ay 1 kasi hindi tayo nag-round off. Kinuha natin yung eksaktong values. So, yun, ano, magic ng calculator. Pwede kang mag-store ng sagot. Siyempre, para magamit mo sa susunod na computations. And mas precise yung computation, tandaan natin kapag ganito nag-store tayo ng sagot. Kasi hindi tayo nagra-round off. Tandaan, kapag tayo nag-round off, natatapyas yung value. So, magkakaroon ng pagkakaiba. Kaya nakuha natin kanina, 0.9996. But that is approximately equal to 1. Anyway, hindi naman ganun makahalaga yon. That is just to prove that a unit vector does have a 1 magnitude, ano? 1 unit magnitude. Okay. So, yun lang. Sana sa mahabang discussion na yan, pagtiyagaan natin, ano? Okay. So, ganun lang. Antok na ako. Bye.